Okay, good morning everyone. Any questions from the last class? So if you remember, in the last class we finished the logistic regressions. So if we just go back little bit about the logistic regressions, I want to mention two things. One, when we feed the models with the one categorical variables, which is our response variables, with two categories, and our predictor, which is our, in this case, age, which is continuous, and we get these two parameter estimates. Now keep in mind, these two parameter estimates can be interpreted in terms of the probabilities or in terms of the log odds. Now they are not in the linear form. So if we think that, okay, this is an intercept, this is the slope, well, if we just think that, okay, for 1 unit increase in age, whatever the, for 1 year increase in age, the predicted, what is called the, our response variable was, in this case, the predicted value of this, the person subscribed to a newspaper will increase by this. No, because this is not what we are looking for. Rather, we should say that for 1 unit or 1 year increase in age, the log odds will increase by this, because this is, these models are fitted based on this. Keep in mind. So this is our log odds. This is what I said in the last class, if you remember. And when we fit these models, so we make it a linear in terms of the log odds. So whenever we are interpreting, we should say that in terms of the log odds. Now in terms of the probabilities, when we if we look at the probability, then we can see that the probability can be written in this form, which is called the probability that someone subscribes to a newspaper, which is y equal to 1, depending on their age, is this. And this one we can write it down this. So we have seen earlier about this part. Now this is our model parameters, estimates. Now I mentioned here that if we say in terms of the log odds, so we can say that as x increases, beta 1 tells us about the change in the log odds, and beta 0 tells us about the expected log odds. Now if we look at this one, before I go to our exercise, so here if you look at this one, this is our fitted models. Now I would like to interpret these two, especially the age, which is the slope. So we can say that in terms of the probabilities, because we can see that this is increasing, the chances that the subscribe to a newspaper is increasing, so we have the positive slope. So, and this is significant as well, age is significant. So we can say that if age is increasing, so we can say as age increasing, we have a significant positive increase in the probability that someone subscribed to the newspaper. Is that clear what I said? We have positive increase in the probability. This is not the value of the probability. We are saying that this is the positive increase in the probability. So how do you know that what is the chance that someone subscribed to a newspaper? So you have to plug in the value of age here to calculate the probability that someone subscribed to a newspaper. And this one you can calculate it by using any value of x. So for example, if you plug in any value of x, you can see that, okay, what is the chance that the age is this? What is the chance that someone subscribed to a newspaper? Okay, for a particular value of age. But in general, we can say that if age is increasing, someone subscribed to a newspaper is increasing. So you can say there is a positive increase in the probability that someone subscribed to a newspaper. And why I am saying that significant? Because we know that this is significant. Now, alternatively, if I ask you, okay, interpret this slope, this one, in terms of the log odds. So in terms of the log odds, this is different. So we can say as age increases by 1 year, because age is measured in the years, the log odds is increasing by this. So the log odds that someone subscribes to a newspaper, actually here, the increasing means here that someone subscribes to a newspaper increases by this. Make sense? Any questions? So that's the 2 points that you have to keep in mind. We can interpret this in terms of the probabilities or in terms of the log odds. Okay, so now next part was our these questions. We use this chapter flu shots data set. So let me go and open this data one more time from the class questions here. So you can see this is our data here. Now I would like to fit the models, okay, using the logistic regressions. Yes, is the actual meaning in terms of the log odds. You mean the log odds? Yeah, it seems that log odds does not have a meaningful yes, it's a meaningful interpretation, because the log odds is the actually the, what is the odds? Odds is the, like when we say the odds, which is the probability of success divided by the probability of failures. Now if you take the exponent of this, we can get the odds ratio actually. The odds ratio, it's a very important measure that we use in the logistic regressions. So the log odds is just taking the transformation of the odds. What is the odds? Odds is the ratio of success divided by the failures. Now we can see that, okay, if we say that this ratio is higher than 1, then we can see that, okay, the ratio of, like, the probability of success is higher, these times higher than the failures, something like this we have seen earlier. Now the log odds is just taking the logarithm of this one to make it linear. But whenever we express in terms of the log odds, we just say that in terms of the log odds. But if you want to go further, then you can just take the exponent of this one. So for examples, let's go back. This is what the logistic regression we can see. Now this is the log odds that we have seen. Now if we take the exponent of this one, what we gonna get? E to the power, like we call it the exponent. We have here e to the power, I'm not sure, and I can show you any, maybe the Desmos one. I don't see here e to the power, the exponent one, but let me show you with any other statistical software. For example, here, so if I take the e to the power, you don't need to know how I am calculating, just you have to know that e to the power of this, whatever we got it here, 0.131, So what we got here, we get 1.1399 this. So this is the ratio of whether a person subscribed to a newspaper divided by the ratio that someone did not subscribe to a newspaper. This is the ratio of the two odds. So this is called the odds ratio. Now, Odds ratio tells us that someone subscribed to a newspaper is 13% higher than someone don't subscribe to a newspaper. So this is what the odds ratio tells us. So we can see the chance of subscribing to a newspaper is higher than not subscribing to a newspaper. Does that make sense? Any questions? Okay, so I don't see any questions. If you are still confused, let me know what I said. So don't hesitate to ask me questions. I'll be happy to answer any question that if you ask. Okay, now next part is we are looking for here in these questions. Okay, so we already fit these models. Okay, let me see what you asked me. Thank you for the clarification. Okay, now next one, let's refit this model because we want to fit it one more time, otherwise we cannot see what we got last class. So analyze, and I showed you that, okay, fit models. So let's go and do the fit modeling. Now, as I told you that you can change it to the categorical variables to the numeric one. If you don't change it, it will not change anything. So this, now we are looking for which variables here, fitting the models based on all these three variables. I think so. Let me check the questions. Multiple regression set to see the relationship of all the predictors. Yes. X1, X2 and X3. Now, one thing you can notice that when you choose this one, it automatically choose the nominal logistic. Now that's a good thing, but if you, for example, if you go, so I want to show you both ways. So this is one way that if you don't change anything here in the response variables, okay, you have to make it continuous first. That's what I want to clarify. Look, if we don't make it continuous, this is the last question that Jack asked me in the last class, that what is the difference? Can you make it continuous or can we put it like this? Yes, you can put it both ways. But if you make it continuous, so I want to show you that, yeah, this is what I said in the last class, it will not change anything. So this is, here you can see that the nominal logistics, so they are actually running the logistic regressions for you. And let's look at this one first. So this is our logistic regressions that we get it here based on what we fit the models. You can see our p-value is this one, parameter estimates is this one. Now let's go and change this one to the continuous variables. Column info, you know how to do the changing. So numeric to continuous. And do the logistic regression one more time. Okay. So y is our response variables and these three are the predictors. Now one thing you can notice here in the right hand side, this is there by default, it is they are considering that you are fitting a multiple regression analysis, because the response variable they are considering is a continuous jump because we make it continuous. Now what you have to do here, you need to change it to the generalized linear models. Okay, now they're going to ask you what is the distribution. So for the logistic one we are selecting the binomial one, and you can see whenever you select the binomial you get the logit, and then run this one. We run this one. Do you see any differences here in the parameter estimates and the p-value? First of all, look at the overall model. The p-value is this one, and go back and look at our p-value here. So if I put side by side like this, So the p-value is this, full model is this, reduced model is this. The chi-square values here, if you go back here, the chi-square values are same. The little bit changes here comes in this 3. The coefficient just, so the chi-square, so look at the chi-square value, okay. 6 point, so first one is intercept is same, but when you feed the chi-square here, the world chi-square, okay. So these values here, you can see little changes here, only the comes in the like to ratio 1. So we are looking for the parameter estimate. So intercept, these are no changing here. Can you see any changes here in the parameter estimates? We don't see any changes in the parameter estimates. The p-value changes, but it's still the same, giving the same result here. So this one is insignificant, this one is insignificant, this one is insignificant. These two are significant, only this one is insignificant. Is it clear? But for the simple logistic regression, you will not see any changes. But still our model conclusion is same because the parameter estimate does not change anything. Okay. But we always make it continuous to see the logistic regressions. But you can do it both. Okay, now. So since I showed you the continuous one, so I'll continue with this one, with the continuous predictor. So here, if we look at this output, we can see here x1 and x2 is significant, x3 is not significant. Okay. Now let's go back. We already, the overall model is useful or not. We have seen earlier that this is useful. How can we decide this one? We look at this whole model test and then find it out. The next one, based on the result from the JMP output, that we see that age and health awareness of the clients are significant predictors. Now interpret the parameter in terms of the probability of getting a flu shot. Okay. Now we would like to interpret this in terms of the probability of getting a flu shot. Now, since the x3 is not significant, so we are not caring about the interpretation of x3 which is here. This one we are not caring. Now we would like to interpret these two. So what can we say in terms of the probability? Can anyone tell me? So what is our y here? So if you go back and then see, y is that if they received the shot, the client was coded as 1, otherwise they coded as 0, and the x1 is the client age and x2 is the health awareness, and we are not caring about x3 because it's not significant. So health awareness, client says, and whether they get a flu shot or not. Okay. Based on this, what can we say about this interpretation in terms of the probabilities? All we can say that there is a positive chance, or the probability is increasing, or we can say there is a significant increase in the probabilities whether someone get a flu shot or not. So this is what we can say only, because we don't know what is the probability. Because if you want to calculate the probabilities, then we have to put the value of x1 and x2. But here we can say only thing that if the client's age is increasing, we have a significant positive increase in the probability that someone got a flu shot. Make sense? because we are looking for the first one is axon, which is the client's age. So we can say as, please stop me if you are still confused what I am saying. As age increases, so what I said here, we have a significant positive increase. What else we can say, that if age is increasing, there is a significant positive increase, that someone get a flu shot or the clients get a flu shot. So you are saying that significant positive increase, because if you go back here, we can see that this is here, the estimated value is positive, and we can see here and also you can see that how you can notice here. One thing you can always look at for yourself when you are doing this, we can look at the profile plot. Okay, how can you get the profile plot? You can go to the profilers and the profiler here. Now if you go back here, so you can see that here for the age and the someone get a flu shot is increasing. So you can see that there is a significant increase in the probability that if someone get a flu shot here, because as age is increasing, here you can notice very clearly that as age is increasing, because we know that there is a significant relationship, so we can say as age is increasing, so there is a significant positive increase that someone get a flu shot. Clients a flu shot. And if you match this on, you can see what I said here for the positive increase in the probability that someone subscribed to a newspaper. So we say that there is a significant positive increase, or we can say there is a significant increase in the probability that someone subscribed to a newspaper. Here we are saying there is a significant positive increase in the probability that, but increase in probability that someone, the clients get a flu shot. Okay, now what about the next one? I think next one you can tell me. So what is next one? Health awareness. So if health awareness increases, the probability of getting a flu shot. No, but if you say that by 0.0989, that's something you are confusing. Why? Because this is not the probability. Look at this. So the log of, so look at this now. Then Priyanka is, what is telling, that Priyanka is telling something like in terms of the log odds. But we are not interpreting in terms of the log odds. I said that interpret this in terms of the probabilities here. In the context of getting a flu shot. So this is the probability of getting a flu shot. But you can ask me, how do I know what is the probability of getting a flu shot? Exactly, if you want to find the probability of getting a flu shot for a specific value of x, then you have to use these equations. Okay, here you have x1 and x2, and then you can get, okay, probability of getting a flu shot for a specific value of x1 and x2 is this. But now whenever you are saying that, okay, what is the chance that someone is getting a flu shot when age is increasing, only you can say that, okay, whether they are there exists a positive increase or the negative increase. And it's clear that you can see if you look at the profile pictures or the profile plot for individual value of X and the probability that someone get a flu shot. So you can see here as X2 is increasing. So what is X2? In our case, X2 is the health awareness. Okay. So health awareness. So as X2 is increasing, there is a significant decrease in the probability that someone get a flu shot. So this is what we can only say. We can see that when X2 is increasing, there is a significant, this is the probability. Here, this line shows that what is the chance that someone get a flu shot when for a specific value of X2. So now, as X2 is increasing, because we don't know exact value now, because we can just see that this coefficient tells us what is the chance. But this is not exact value of the probability for a particular value of X. If you want to get the particular value of X, then you have to plug in this into these equations. These are the equations. Okay? Because this is the general equation. If you go back, I showed you earlier at the beginning of this. Here, no matter what the value is, so if you have two variables, you just put another variables and then calculate these probabilities depending on the value of X. Okay? How do you do an examples with the probability formula? Can we do an examples with the probability formula? So what do you mean by the probability formula? Like calculating the probability, you mean? The one you are just talking about. Calculating the probability, we are going to the next examples is the calculating the probability. If you go back here, you can see I ask you here. The first person in the data set, ID is 81 and who have a systolic blood pressure and this, what does your final model say about the chances of surviving to his visit to ICU? Here we are going to calculate this. So I put another examples, how to calculate this probability. Okay. So here we are just interpreting this. So keep in mind the interpretation is very important. Okay, so if we look at this, we can see that if X2 is increasing, that means if health awareness is increasing, there is a significant decrease in the probability that someone or the client get a flu shot. So we can see, so as the health awareness increases, now you can ask me why you are saying the significant, because we have seen already the p-value is smaller. Okay, so that's why I spend much time here, that if I ask you interpret this in terms of the probabilities or in terms of the log odds or log odds, if you just take the exponent, it's the odds ratio, nothing else. Now, intensive care unit, this is the data set that I uploaded in ELC. If you go to the class questions data, you can see this one. Now, in this data set, show that for information for a sample of 200 patients who were part of a larger study conducted in hospitals intensive care. Since an ICU often deals with the serious life-threatening cases, so a key variable to study is patient survival, which is coded as the survival variables as 1 if the patient lived to be discharged and 0 if the patient died. So we can see that this is we are looking for the survival status. Among the possible predictors of these binary response variables are age in years, age groups, sex, infection rate, okay, whether if the infection is suspected or no infection, and systolic blood pressure, okay, which is a continuous variables, pulse, heart rates, emergency admissions, and consider multiple logistic regression. So here we are not considering all the predictors. So consider a multiple logistic regression for survive using the three quantitative predictors in the dataset: age, systolic blood pressure, and pulse. So let's open this dataset in JUMP. So if you go back to our logistic regression, here you can see ICU. So please open, everyone, please open your dataset here. Maybe I can just close all these things from the flowcharts. Oh. No. Okay, so this is our dataset. So you can see that we are interested in the survival status. So we'd like to know whether a person survives based on their age and systolic blood pressures and the pulse rate. So these are the three variables that we are considering here: age, systolic blood pressure, and the pulse rate. And three of them are continuous predictors. But our response variable is categorical, and is two categories. So after running the three predictor model, does this appear that the overall model is useful or not? So we need to answer this question. So first of all, we know that we are going to do the logistic regressions. Why? Because our response variable is categorical. So let's do this part. So now, since the survival is here already in continuous, so we don't need to change anything, that's fine. So feed the models here. Our survival is our response variables, where our predictor is age, systolic blood pressure, and pulse rate. Okay, now we need to change it to the generalized linear models, the normal one, the binomial one, and the logic. Okay, now if you run this one, so we feed the multiple logistic regressions here, you can see. So is the overall model is useful or not? We always look at the whole model test. So whole model test, they compare the full models and the reduced models. So full model is the model that consider all these three predictors here, and we can see that the full model is, the p-value is small. So since the p-value is small, so we reject our null hypothesis, and we can say that yes, the full model has a significant effect. So we can say that full models here, like all these three predictors. So here, so the overall model is useful. So based on the JUMP output, from the whole model, so what is our p-value here? 0.007, 0.0007. And you know that I did mention that, okay, which level. So always by default we use 5%. So p-value is less than 0.05. So we can say that the overall model is useful. Now the part B, I ask you that based on the results in part A, which of the individual predictors are useful? Does it appear that any of the three predictors are not very useful in this model to predict the survival rates in ICU? If so, drop one or more of the predictors and refit the model before going to the next part. Okay. Now let's look at this. So how can I check this on? We go to the individual parameter estimates here, this part. Now we look at this, we can see that age and systolic blood pressure is significant, pulse is not significant. Now I ask you, okay, if N1 is not significant, so we can drop this and refit the model. So how can we drop it? So we go to the effect summary here. Please stop me if you cannot follow in the jump. So effect summary, you can see that the pulse here, which is, we already seen that this is not significant, and they always put the p-value in the order of magnitude here, the smallest and then second smallest and then so on. So the last one, the p-value is high, so we select this one and remove this. When you remove this, that means they refit the models. Now you can see that after refitting the models, we can see these two are significant, we already have. So we can see, so this part we just do it based on the results. We can see, first of all we can see when we fit the models with the three parameters, we can see based on the parameter estimates, the only age and the systolic are significant, but what was the other one? Pulse is not significant. So we remove the pulse from the model and refit the model. Okay. So we refit the models, and then since here I am just doing this part, I am not putting the output, so you need to put the output. Like first of all you need to put the parameter estimate including three predictors, and then after that you should say that okay, based on these parameter estimates you can see only age and the systolic blood pressures are significant, pulse is not significant, so we remove the pulse from the model and refit the models, and then you put these parameter estimates for the refit models, this part in here, and this will be your answer for this part. Now the next one is the Emma that you asked me the question that how we can calculate the probabilities and so on. So here we are doing this part. The first person in the data set, ID number 4, is an 87-year-old who had a systolic blood pressure is 80 and heart rate of 96 beats per second when he checked into ICU. Now what does your final model from part A say about this person's chances of surviving to his visit to the ICU? Okay. Now, did I look at the age, systolic blood pressures? Okay, yes. Now whatever the parts, heart rate is like this one. The pulse is 96, but we don't have the pulse actually here in our models. Maybe we can just use instead of the pulse, the blood pressure is this and 87 years old, and the heart rate is this when you checked into okay, no, it's okay, because it's only said that what does your final model from part A say about person chances of surviving his visit to the ICU. Now our final models, we know that this is our final model. So if you want to write these final models, how can you write these final models? These are final models. So we can say the logit of what? Pi over 1 over pi. So we can say pi, maybe I can just use the symbols. It's better to write it down like that is what we have. Logit, okay. Let me see what's the time, because I have another appointment. Okay, so here. So the pi, we know that probability that someone subscribes to a, that someone survive when they enter into the ICU. So pi 1 minus pi. So these are logit models. Now this is equal to what? Beta 0 hat. So what is our beta 0 hat in this case? 0.9625, 0.9625. Okay, plus next one is negative, so we can put the negative 0.0284. So we can just put the negative 0.0284, I think is, plus 0.0168 systolic blood pressure, 0.0168 SIS, okay, BP. So this is our models, okay, fitted models, the final models that we get. Now we would like to know this, what is the chance that someone, okay, what is the, here I ask you that when you check to this blood pressure, the first person in ID this had a systolic blood pressure is this, and then you want to know from there that the person chances of surviving his visit to the ICU. So surviving his visit to the ICU, that means we'd like to know the estimated value of this. So we can say that the probability that, okay, so it's better to write it down exactly in the symbols, okay, probability that pi equal to 1, or we can say y equal to y, because y is our it's better to write y equal to 1, which is that someone given that x. What is x here? All these two predictors. Okay, how can we write this probability? So we know that this is the probability that we know it 1 over e to the power, okay, this. So I am just using this formula that we have seen earlier, e to the power. So if we go back, see what we have, e to the power this minus beta 0 plus beta 1 x. So we have plus beta 2 x2. So I am just putting this one minus beta 0. So it's better to put a bracket here. Okay. So beta 0 means in our case I can just put it this one exactly what I have. So 0.9625, okay. Now this one is negative, so we can say 0.0284 times age. So what is our age here? We said that 80 years old, so we put 80 here. Now this one, I am not putting this exactly what the formulas, I am just plugging the values. So 0.0168 times the value here, the systolic blood pressure, you can see 80, so you plug in 80. So this will be your probabilities that someone, so let me make it bigger. Can everyone see what I said? This is the probability. Maybe Emma asked you that how we can, now you can say that the chance that someone subscribe to a, someone get what is called the survive is this. When x is this, y, x1 is this, x2 is this. But this one is not the someone survive, this is the chance. This is not the chance. This is what we have the estimated values. So I think age should be 87. Yes, you are right. Thank you for clarifying this. The age is 87. Yeah. Okay. So I hope you get what I mean by this, and then this one is easy to calculate if you use any calculators, graphical calculators, scientific calculators, or any statistical softwares, you can calculate it. And this will be your probability for a specific value of x. And that's why I didn't say that this is the probability that the age is increased and the probability is this. No. This is here you can only say as age increases by 1 year, the log odds is decreasing by this. Or you can find out the odds ratio by taking the exponent of this. Okay guys, so please stop me anytime if you have any questions, and today I'm just leaving little bit early and hope to see you in the next class. And please, if you have any question about homework, you can ask me. And next class we're gonna start the new chapters, and you can see I already uploaded the new chapters. Thank you all. Have a nice weekend.